All right, guys, we are talking about function transformations. And we're specifically going to be using the absolute value function to model that. That's because we've been working with the absolute value function, correct? Okay. Our function transformation rules that we're going to learn for absolute value will apply for every other function that we learn for the remainder of the year. Okay. That'll be our quadratic, our cubic, our square root, our cube root, our exponential, our log. It will apply to all of these functions for the rest of the year. Got it? It just will look different for each one. Okay. So up first, we're going to talk about translations, vertical translations. For vertical translations, you're either going to go up or you're going to go down. Okay. Last week we learned. Are we okay? All right. So last week, we learned. Well, we've been working with the absolute value function. The absolute value function is f of x equals absolute value of x, right? And it makes a V shape. So on your foldable, all you see are the V shapes of the parent function, okay? And we're going to be manipulating it, moving it left, right, up, and down. Anytime it asks you, how was a transformation, how was a function transformed? It is based off of how did it change from the parent function? Does that make sense? So how did I change from the parent function? All right. At the top part here, you should have room. We're going to write what its full on parent function is. Now, we're going to have to write it diagonally because I think I did, but I don't know how big you'll write. If not, you should have enough room to write it all the way across the top, okay? So ultimately, our transformation function looks like this. It would be plus or minus an a value and then we would have absolute value plus or minus a b value, meaning that it can be positive or negative, parentheses, minus a h, close parentheses, absolute value, plus a k. Okay? So we're going to learn what each one of these variables do. Does that make sense? Okay, we've learned that our vertex is our h and our k. Do y'all remember that? Your vertex is your h and your k, which logically tells you that you're going left, right, up, and down. Does that make sense? And then from there are the other features. So again, this is absolute value. And the main new things are A and B we're going to be talking about. Got it? All right. So up first, vertical translation. So we have f of x plus k, f of x minus k. F of x is our absolute value function. F of x equals absolute value of x. Okay. We're going to graph this in terms of g of x. So our graph that we create is going to be called g of x. G of x equals the absolute value of x plus 2. Okay? So g of x equals absolute value of x plus 2. Now I'm going to show you guys in Desmos. So in Desmos, we're going to graph our original, our f of x. So we have f of x equals absolute value of x. Yes? Everyone's with me? To make the absolute value, you either can type ABS or you press shift in the button above enter, where you should see a line. I typed it.
No, how do you see it?
I typed it. Oh, it's just a number. It could be any number. K can be any number. I'm using 2 because as you can see, our graph isn't very big, right? So I can't make too big of translations, okay? You press shift and there should be a button above your enter that's a straight line. Okay. All right. So now we're going to type in our g of x. G of x says, sorry, don't capitalize. G of x equals, you can write it one or two ways. You can write it as f of x plus 2. because it's saying I'm taking f of x and adding 2. I'm shifting it. Does that make sense? So you can write it that way because I'm only moving the parent function, or you could just write it as absolute value of x. Take out the rest. Too many x's. Hold on. There we go. Okay. Do we get it? Same thing, because it's just substituting in what f of x is. Does that make sense? Okay. All right. So what did it cause it to do? Shift up 2 units. Make sense? All right. So now, what do you think if I now do h of x and let that be absolute value of x minus 2 is going to cause it to do what? Shift down. Now, a big misconception here is that you think the size of the absolute value changed. The size did not change. Your perception of it did. Does that make sense? How much of it you can see change, but it's the same width. It's just that you're seeing it at a different angle. Make sense? Okay. So the size does not change just because your K value changes. All right. I hate when that happens. And we're like, oh no, it got bigger. No, it did not. It just moved down. So I see more of it now. Okay. All right. So on here, for our g of x shifted up 2 units. So every point is just going up 2 units. Does that make sense? Up 2 units. Okay. So when I shift up 2 units, how does that affect my domain? Well, your domain is never affected. Okay. Your domain is not affected because it goes from negative infinity to positive infinity, meaning that it's all real numbers. It goes forever to the left and forever to the right. Okay. However, your range is affected. Your range depends on what is your highest or lowest value, correct? In this case, it's our lowest. So our y value is greater than or equal to 2. Does that make sense? Okay. When we did h of x, we had absolute value of x minus 2. It caused it to go down. The domain stayed the same, but the range changed, right? The range went down to negative 2. So now it starts at negative 2 and continues to infinity. So my points are now like this. And again, remember, the size of it didn't change. Just what I can see changed. Does that make sense? Remember, pretend that these are the straightest lines you've ever seen. Oh, I couldn't even let that one make it. I wanted to, but it was terrible. That one was kind of bad. Oh, wow. Look. There we go. Told you. Okay. How do we feel about vertical translation? Yeah. Yes. It's my lowest. Okay. Now remember, there are 2 ways of writing your range. You can write it in an equality notation, which is saying y is greater than or equal to, or y is less than or equal to, right? Or you can write it in interval notation, saying I start here and I end here. Does that make sense? Interval is telling you where you start and end. Inequality is telling you your lowest or your highest. Okay. Is that a positive? This is positive 2, right? Yeah. And this one's at negative 2. All right. Now we're going to go into horizontal translation. For horizontal translation, what we need to remember is that our x's are, okay, your x's lie, meaning that when you're moving right, you're actually subtracting, okay? It looks like you're subtracting, but you're actually adding to your x values. Oh, that's what I forgot to write here. I'm sorry, guys. When you have plus k, if you're looking at your y's, this is meaning your y values plus k. This means your y values minus k. Forgot to add the little what it means. So to each y value, notice we added 2, right? To each y value, we subtracted 2. Okay? Because x's are liars, what's actually happening here is to each of your x values, you're actually adding whatever h is. So to each of the x values, you are actually adding h, which is why it's going to the right. So our g of x here would equal the absolute value, and notice that it's on the inside this time, of x minus 2. Because I'm substituting. Function notation tells me if it's on the inside, that's what I'm replacing my x with. So if I have x minus 2, that means that this function is going to move 2 units to the right. And every point is going to move 2 units to the right. Okay, and that's because you're adding 2 to each one of your x values. And 2 can be any number, right? We're just choosing 2 to fit our graph. Okay? Does that make sense? Okay. So then for our horizontal translation to the left, it says f of x plus 8. Oh, sorry. F of x plus 8. Again, x's are what? X's lie. So this actually means that to each one of my x values, I'm subtracting h, which is why it's going to move to the left. Okay? So when we have our h of x here, h of x equals the absolute value of x plus 2, which means to graph this, I'm taking each point and subtracting 2 from it. 1, 2, 1, 2, 1, 2. So my new points are now we did G right there. That was for vertical. Now we're on horizontal. I'm using G and H the whole time. Okay. It's just the name of the function. Remember, functions have names, right? That's it. G and H are just the name of the functions. It doesn't change anything. It's just what the function is called. So for horizontal translation, the domain is still going to be negative infinity to positive infinity, all real numbers. The range. What is your range now? Range has never been all real numbers. What is your lowest y value? So y is greater than or equal to 0. Does that make sense? Okay. Your domain for h of x here. Domain here is negative infinity to positive infinity. And your range is also from 0 to infinity. Meaning that your y values start at 0 and they just keep getting bigger, right? Yes, there's a roll on my desk. All right, now we're going to talk about reflections. So for reflections, before we do it, we're going to go back to our Desmos, okay? So we're going to go to Desmos. I'm going to change these. Our parent function is still the absolute value of x, okay? Now we're talking about reflections. How is reflecting this going to change? So our reflection over the x-axis is our first one. And that's going to be g of x equals, and it's going to be a negative on the outside of my absolute value. So there's a negative on the outside of my absolute value. What did it cause my function to do? It reflect, right? It reflected over the x-axis. Do we see that? Okay. That means mathematically what took place? Anyone? How did it reflect? Like, what did I do? What did I add, subtract, multiply, or divide? I multiplied by what negative number? -1. I multiplied all my y values by -1. So if you look here, here were my y values before, right? And then now if you look at this one, pull this table, look at the y values now. They are opposite, right? They all have been multiplied by -1. Do we see that? Okay. Easy peasy. All right. Now, h of x works a little different. So if g of x with the negative on the outside reflected over the x-axis, what happens when you put it on the inside? Okay. Superintendent Stahl? The board. You got the high school kids on board. The panel? Yeah. Okay. All right. Notice here, I put the negative on the inside, but did anything happen to the parent function? No. Oh my gosh, I messed up. Darn it. No. What makes absolute value special? They turn things positive. It turns things that are negative into positive, right? So if I put a negative inside the absolute value, it's going to still behave the same. Does that make sense? Yeah. So for absolute value, when you have a negative, you're not going to see that transformation. But what it is it's reflecting on itself, right? It's like folding it in half on the y-axis. It's going to stay the same. Does that make sense? All right. So let's go write some stuff down. All right. So negative f of x, what that means is that we took our y values and multiplied them by -1, right? That's what caused it to reflect over the x-axis. So our g of x that we put in equal negative absolute value of x. And it caused all of our points to reflect over the x-axis. Okay? Just because it reflected, our domain is still unchanged. It goes from negative infinity to positive infinity. However, our range has changed. Our y values are no longer getting bigger. They're now doing what? Getting smaller. So y has to be less than or equal to 0. Does that make sense? Yeah? All right. Reflection over the y-axis, that f of negative x is a special case, right? So that f of negative x may be hard to see with just the parent function. All right. What that means is that we're actually taking our x values and multiplying them by -1. But the thing here is that it's symmetrical, right? Our parent function has y-axis symmetry. I'm just going to slide that in there. And because it has that y-axis symmetry, when I reflect right over the y-axis, you're not going to be able to see that difference, okay? So when we graph h of x equals absolute value of negative x, it still is going to remain and even though I'm tracing lines, you'd think I would be able to make them straight, but I wasn't. Okay? Thank you, thank you. So the negative infinity to positive infinity, and the range is 0 to positive infinity. All right, questions about reflecting? No? All right, the next thing we're going to talk about is stretch and shrink, okay? I want y'all to know that sometimes you may hear shrink as compress. It's the same thing. So if I accidentally ever say stretch and compress, it means the same thing. Once you get into AP, once you go into pre-cal, altogether it's just called a dilation, okay? But for us, it's called a stretch or compress. But specifically, it's a dilation because in geometry, dilation just means that it's a change in the size, right? Whether it's big or small, it's just a change in the sides. Make sense? All right. A vertical stretch means that you are taking your value, which is a, and you're multiplying it times your f of x, which means y. Does that make sense? So all you're doing is taking a and you're multiplying it times all of your y values. Are you with me? So you're taking your a and multiplying times all of your y values. All right. So if we have our parent function and we have g of x equals 2 absolute value of x, all I'm doing is taking each one of these y values and multiplying it by 2. Does that make sense? So 0 times 2 is 0. 1 times 2 is 2. Then we have 2 times 2 is 4. Same thing over here. Do we see how that happened? Okay. But if we also remember just how to read an absolute value function, remember this number on the outside is the what of that function. Starts with an S. What? What is this 2 normally? Well, what did we learn this 2 represents for that function? Rise over run. It's the slope of the right side, right? It's your slope of your right side. I'm going to go up 2 and over 1. Am I at the same spot as me multiplying? Yeah. Up 2 and over 1. Am I at that same spot as me multiplying? Yes. And because it's symmetrical, I know it's going to reflect onto the other side. Okay. All right. So when you have it did. So when you have a vertical stretch, it's going to make your graph skinny. Think about your graph is now working out more. I'm going to double my workout, right? Okay. I'm going to double my runs. So it's going to get skinny. All right. All right. Your domain again is not changing. Negative infinity to positive infinity. Did my range change? No. My y's are still greater than or equal to 0. Okay. So if a vertical stretch, that means that your a value is greater than 1. If it's a vertical shrink or compress, that means your a value is between 0 and 1. It's a fraction of 1. Does that make sense? So if your a value is a fraction of 1, you are still just multiplying it times the y. So it's still a times y. However, it's just now a fraction, which means that if I cut my workout time in half or my walks in half, what could possibly happen? I can gain weight. So instead of me getting skinny, I'm going to get what? Wide. We could just said wide, guys. We could have just said wide. So we have h of x equals 1/2 absolute value of x. So that means I'm taking each one of these points and cutting them in half. Okay. The other thing is, remember, this is the slope of your right side. So if I'm here, I'm now going to go up 1 and over 2, up 1 and over 2. Then I reflect it, up 1 and left 2, up 1 and left 2. So notice when I cut my workout in half, my walks in half, I got a little bit wide. Okay. So a vertical shrink or compress is going to cause your function to get wider. Okay. So the domain here is still negative infinity to positive infinity, and your range is still 0 to infinity. Your graph is just now looks different. Make sense? Our last but not least is horizontal. How are we changing horizontally? So our horizontal stretch and shrink, remember X's are liars, not what you think, okay? So a horizontal stretch, actually, well, your A on the inside, the main thing here is A has to be factored out. So like if it was AX, well, I'm sorry, it's not an A, it should be a B. Did I change y'all's on your paper? Okay, good. It is, but go with it. B, the B, okay? If your B value, instead of multiplying your X by that, you're actually dividing. It is X divided by B. So you're changing all of your b's by dividing. You're dividing. Same thing here. It's going to be x divided by b. Okay. So if we let b be 2, this would be our g of x now. And g of x would equal absolute value of 1/2 x. Okay. If you're dividing by half, that's the same thing as multiplying by 2. Do y'all understand that? So dividing by half is the same thing as multiplying by 2. So imagine all you're doing is taking each one of your x values and multiplying by 2. Okay. So it ends up being here. I'm here. This point is at 1, 1. Well, what is 1 times 2? 2. So instead of it being at 1, 1 is now at 1, 2. Does that make sense? This point is currently at 2, 2. What is 2 times 2? 4. So its new home is now at 4, 2. I'm going to repeat on the other side. And because they're symmetrical, it's just going to what? Oh, I didn't go high enough. Thank you. I didn't go high enough. Oh, yes. Low enough. Yeah. Yep. Sleep is necessary.
Right? That's why it should snow. That way we don't have
It snowed and went away.
it's not right away.
Okay. What do you notice about our horizontal stretch? It actually does what? It gets wide. It's a stretching horizontally means that it's going to get wider. It's going to behave like a vertical. Do we see that? It's going to behave like a vertical compression. Okay? Just unnecessary.
It gets chubby. That's how it's
Why can't we just say wider?
No.
I'm telling you what to say, and you're ignoring me. Absolute value of 2x. So again, now you're dividing your x in half. Okay? So you're now dividing your x's in half. I'm not going to divide 1 in half because it's just not easy, but I will divide 2 in half. Okay? So if I divide 2 in half, that's going to put me now at 1, 2. Does that make sense? If I divide 4 in half, which is at 4, 4, that's not going to put me at 2, 4. If I divide 0 in half, it's still going to be 0. And because this is an absolute value, it's going to mimic the same behavior. It's going to get skinny, and it's mimicking. Oh, man. A vertical stretch. That's what I was looking for. Thank you very much. Okay, so it mimics a vertical stretch. Do we see that? All right, the domain here. So the domain is still negative infinity to positive infinity. The range is still going to be 0 to infinity. Make sure when you write it, it's a bracket if you're not using inequalities. The domain here is still negative infinity to positive infinity. And the range, just so we get used to it, is y is greater than or equal to 0. Remember, these two things mean the same thing, just written 2 different ways. Okay? Oh, I forgot to write skinny.
Skinny and fat.
Whatever helps you remember.
Why are you born for you?
I guess.
Skinny and
all right. So what you're going to do is to make sure, this is like our little exit ticket, it's our practice to make sure you understand what we did, is when you go to your assignment, I think I may have to reset it, but you're going to have a Google slide assignment. And on that Google slide, you're actually going to replicate the transformations, okay? Okay, so you're now moving the arms. So if I have absolute value of x plus 2, where should it be, right? If I have, okay, you're replicating. Now, before I let you free, I want to show you guys something. Now, your transformations can be combined, okay? So for example, if I had negative 2x minus 3 plus 4, there are 4 transformations taking place here. Do we see that? there are four things from our foldable happening. You have a negative on the outside. A negative on the outside of my absolute value means what?
Everything.
It's doing what? It's reflecting over the what? X-axis. So I know that this graph should reflect over the X-axis. Then now I'm going to look at the 2. The 2 on the outside tells me it's going to be a what? Multiply by 2, which means it's going to do what? Am I doing what? Am I stretching or compressing? I'm getting skinny. So that's going to be a vertical stretch. Next, I have on the inside X minus 3. If I have X minus 3 on the inside, what is happening? And that means I'm moving to what direction? X is a liar, so I'm going positive. I'm adding 3, so it's going to cause me to go to the right. And then if I have that plus 4, that means it's going to do what? Go up. So that's how you describe what takes place. So to show you how correct we are, did everything we said take place? Yes. Did my function reflect over the x-axis? Yes. Did my function move to the right 3 units and up 4 units? Yes. Did my function get skinny? Yes. So that's why we do each tab. Each tab has a role, and you have to pay attention to each one. Okay? All right. This should be on page 70 in our handy dandy notebook. Okay, your foldable is going to go on page 70. All right, any questions, comments, or concerns?
Then if you go back to that one thing, the notes.